speaker for the day is Mr. Geet Modi. Ladies and gentlemen, Mr. Geet Modi is the Manager Application Engineering, Internet of Things and Wireless Connectivity Solutions in Texas Instruments. After graduation from Government Engineering College, Rajasthan, he did his master's from IIM Lucknow. He was previously working at Flextronics Software Systems and Hughes Software Systems as Senior Technical Leader and SIRF Technology as Senior R&D Manager. Ladies and gentlemen, today Geet will be talking about the topic Realizing IoT with Texas Instruments Simple Link Wi-Fi CC3200. Ladies and gentlemen, clap really loud and welcome Mr. Geet Modi on stage.
Yeah. Good morning, ladies and gentlemen. My name is Geet Modi, and I come from Texas Instruments, working primarily on the connectivity technology. And I think as the topic for the day is IoT, so let me start with I think the dream everyone, a lot of us are looking towards, as my earlier colleague also presented, that the way are looking for around a lot of connected devices. The number is varying. It is somewhere 20, it may be 50, but yes, it's a reality. So basically what I will do in my presentation is, like, my plan is that I'll start with from TI point of view, what's driving this growth, and at TI how we are shaping ourselves to help to enable this particular market. And then I will cover one of our particular product which we launched in mid this year, and we'll take you through some of the important applications we are enabling with that particular product. So what's driving this connected world, IoT, where we are talking about around 20 billion or 50 billion devices? In our opinion, I think it's the one. There are 2 or 3 driving factors which are playing an important role. The mobile, which has become the hub for all what we do. Like earlier, it was just used as a calling device, but it has become a center place for doing anything. And a lot of, basically, with as the mobile is becoming a hub for us. Can I have a speaker? Otherwise, I have to just stick here. Audio. Yeah, can I get a normal? No. The mobile speaker?
Mobile speaker.
You don't? Okay. Fine.
Color.
Yeah. So if you look from Wi-Fi point of view, I think earlier it was just a device to talk, but now with more and more technologies coming in, it is enabling a lot of use cases. Wi-Fi Direct, now we can stream the video from our, just. Hello. Like, the Wi-Fi is enabling us to do the hotspot, then do the Wi-Fi Direct. Even we can do the video miracast on the television. And then a lot of accessories are getting enabled due to the mobile app. Some of them important, I will just try to cover the proximity sensor. So proximity sensor is basically enabling the context for some of anything which is there on the home. So one of the use case which I recently figured out for the proximity sensor is that you have kids at your home, and they may go and intrude into the kitchen of your kitchen. So what you can do is that put the proximity sensor at your kitchen, and if you are away from the kitchen, then it will go and lock the doors, and if as soon as you enter, it can go and open the locks.
So a lot of use cases coming around the peripherals or the accessories which are primarily driven by the mobile hub. Similarly, for the proximity sensors, again, the location context is getting a big push. Like a lot of nowadays, at least in the Western world, the shopping malls are installing the beacons, the eye beacons, by which as soon as your mobile comes near to the shop, it knows where you are, and then automatically it pops up the relevant advertisements which are helpful for the particular shop. So a lot of accessories are being driven by the mobile world. Going to the next growth which we are seeing is from the smart energy. Like we know we are doing this even today, that there is a generation of the electricity, it distributes, and then finally we consume. But can we, how to make it efficient? And that's where this connecting all these devices together is helping, is going to create the efficiency. So let me take example of the public lighting. So in this case, basically, like I was going through one of the article where a company named Geet has come up with a lighting which are intelligent. They have a GPS fitted and they are connected. Now how it is helping them? So basically, like if since it is a GPS, so you know the location where you installed a particular light. Now, sitting from a control room, you can draw a fence. Okay, I want to switch on the lights of this particular area. Or let's say there is a fault in a particular pole. You can exactly know which pole has got faulty, and you can directly send your technician and fix it. Even just not that people are, they are now thinking in the next action as well. Can we make it more efficient? Like if there is a traffic, then only we go and enable the light. So basically, let's say if you can sense, okay, there is a traffic coming on the light, it can sense using the sensors and can lit the light, else it can close the lights. So a lot of use cases are coming around this. Similarly, on the efficiency front, I think you already know that a lot of connected bulbs are coming using the mesh networking or the Zigbee kind of technology, and the thermostats. The Nest thermostat is known to all of us. Like it is just a thermostat which got acquired by Google at 3.2 billion. So a lot of use cases which are trying to create the energy efficiency are driving this growth of the connected world. And next is the cloud. So basically, like now, along with the mobile, like we know that mobile we can control things which we are around our things, but we want to go to the next level where we can even control the things even when we are not sitting near to the device. So a lot of growth coming from the cloud, and since the technologies used today for connecting are just not the Wi-Fi, they are Bluetooth and Zigbee, low-pan. So some of these technology cannot directly connect to network. So you need gateways. So because the cloud is all about the networking, TCP/IP is needed. So the gateways, Wi-Fi with the Zigbee or Wi-Fi with the Bluetooth, Wi-Fi with low-pan. A lot of such use cases are coming up which are driving the growth. So what I try to focus on is we may have heard like which technology really is going to help us, or which technology is going to be the key for connected world. So is it going to be the Bluetooth, it is going to be the Wi-Fi, or it is going to be Zigbee? So in our opinion, I think one size will not fit all use cases, and each technology has got their own advantages and disadvantages. So I thought, since this question comes very often, so I thought let me just put a slide and just give you a brief view of which technology has what advantages and how they can fit into a specific use case. So what I am covering here is that in terms of range, there are various technologies which can do the sub-gigahertz, which are and the sub-gigahertz where you can go up to 25 kilometers. But the data rate is very low. But if you go for the Bluetooth or the BLE, the range is very small, but the power is very good. While with the Wi-Fi or Zigbee, you can go up to, let's say, 100-meter kind of range. In terms of throughput, again, like it depends on the use case. If your use case is just transmit some sensor data, which is 100 bytes a day, then you can even go for the Zigbee. But let's say you are looking for some high throughput applications where you need, let's say, audio streaming or the video streaming, you may need a slightly higher throughput. So again, each technology has got their own advantages. What I have tried to show here is that with the Wi-Fi, we can go up to 100 Mbps kind of throughput. The technology is available. But with the Bluetooth, it can be max of 2 Mbps. Then the third important point which comes for this market is the power. Power is critical. Like we are looking for a lot of use cases where the devices should be battery powered, and we wish that they run for multi-year. Because you don't want, let's say you put in a sensor in your garden which can sense the humidity, and based on that you can enable the water to the garden or not, and you don't want to go and charge it every day. You want it to run at least for a year. So again, the power becomes important, and again, each technology has got their own advantages and disadvantages. Like with BLE or sub-gigahertz, you can run even with a coin cell for a year. But as you go for Wi-Fi, Wi-Fi is, it's there in your smartphone and it's power hungry. And it needs a good amount of battery which can last for 1 or 2 days. But there are some intelligent things happening in the Wi-Fi world as well, where some of the products which are coming up where we can support up to 1 year using 2 Duracells. And that's what I will cover in my next part of the presentation, how we are enabling it. Using Wi-Fi, you can do 1 year with the 2 Duracells. And then the fourth important aspect which comes when we are trying to choose a technology is what kind of topology you are looking for. Whether you want to go for a mesh network, let's say you want to do the traffic lighting control, then you need that each pole should be connected to other, and you need a mesh. But for the devices which are specific to your home, let's say for your home, it's okay to be in the star topology where every of the connected device is connected to your home router, and home router is becoming a gateway for you to take you to the internet. So again, it depends on the use case, what you are looking for, and each technology gives their own advantage. Like Zigbee is very good for the meshing, but if you want to go for the star or P2P, then the Wi-Fi, Bluetooth has their own advantages. So just to summarize, basically, if you're looking for the higher range, you can go for the sub 1 gigahertz. But if you're looking for the throughput, Wi-Fi is best. But then again, Wi-Fi needs more power. So again, it's a trade-off. Again, it's a trade-off between the use case you're looking, what kind of battery life you're looking, and what kind of throughput, what kind of range, and based on all these things, you have to make a judgment which technology should we go for connecting the things or connecting the items. So at TI, like we believe, like since each technology has their own advantages, we support around 14 connectivity standards today, and we already have products which are shipping in the market. Be it in the sub gigahertz or the 6LoWPAN, which is basically the IP6 version for the 802.15.4, or the pure path. Then we support Zigbee, R4C in 2.4 gigahertz. So this is Zigbee, as the 6LoWPAN is for both sub gigahertz as well as 2.4 gigahertz. We support Bluetooth, BLE. We support dual technology, dual mode, as well as BT, as well as BLE. And then the Wi-Fi. Wi-Fi, we have multiple products for the smartphones, high throughput, as well as for the low throughput. And I'll be covering more on this product today, the CC31XX, what we call as a simple link. And then we have a technology for the GPS as well, like CC4000, and then we have Wi-Link 8 series, which we are shipping earlier in the tablets and the smartphones. So I'm planning to cover further on this, since I cannot cover all of those technology. I thought let me just focus to one particular portfolio we have, and give a slightly brief about how we are trying to make it to fit to the Internet of Things, where the battery is important, the simplicity is important, and it's not going to be driven by just 5 or 10 vendors as in the smartphone. They are going to be, we feel, going to be, I think, millions of developers who will be enabling these devices. So it's important that the devices should be simple, they should be easy to use, and anyone who has some idea should be able to quickly do a product. So that's the idea, and by which we are starting. We had this particular product, CC31XX, which is a Wi-Fi based product. I will try to touch upon again slightly on the Wi-Fi market, like from Wi-Fi point of view, how we are seeing the growth, what are the key segments where this technology is fitting very well. So starting with the home and building automation, like so since at least in the urban area, most of the homes are now de facto connected with internet. Most of the homes have the Wi-Fi routers. So the Wi-Fi becomes the obvious choice. So a lot of attractions we are seeing in the home automation market, where you want to control your air conditioning as well as your light switch using the Wi-Fi. Then the smart energy, again, this is again a growing market where to do the real-time updates with the network, Wi-Fi is seeing a good traction. Multimedia is again a very unique market where the throughput needs are very high. The range along with the throughput is very high, where let's say you want to do the Wi-Fi audio streaming. Now with today Bluetooth, you can do the audio streaming, but the bitrate you can get is up to maximum 3 Mbps. Now you want to do the HD audio like an AirPlay does, where it runs at 48 kbps with a 24 or 32-bit kind of audio, which needs more than 4 to 5 Mbps. And Wi-Fi is fitting very well in this kind of market. Along with the also in the remote controls, we are seeing a good traction, because most of the TVs which are coming now are smart, which have already a Wi-Fi connectivity. Now, since on the other end you already have a radio invested, if you enable it on the remote side, then you can save on one of the technology, and the Wi-Fi becomes a de facto choice there. If you go for the, let's say for the RF, R4C or the Bluetooth, then you have to go and invest another radio on the smart TV as well. So it's again the cost comes in play by enabling the Wi-Fi on the remotes. And then some of the use cases which are coming on the audio on the remote is that you want to stream the audio. So I think Roku launched a product last year where they had this Roku TV along with the remote with a Wi-Fi. So what they are doing is saying is, okay, in the night you want to watch the television, but you don't want to disturb others. So they have enabled audio streaming on the remote. You can attach a headset to the remote, and then you can directly stream the audio from the TV without disturbing others. Security, safety, again, it's a high throughput requirement where you want to stream the pictures live, or you want to do the baby monitoring kind of use cases where the throughput becomes important, and we are seeing a good growth in this market. And then the industrial M2M communication, where the throughput amount of devices which has to be connected is high, and there is a good traction coming in this market. Also, like in this industrial, what we are seeing is that there are a lot of places where humans do not want to go. Let's say there is a electricity panel and it's hazardous to go nearby. So what people are doing is putting a Wi-Fi as a access point mode, and then using the smartphone to do the diagnostics or to do any fault detection. Again, like a lot of use cases, I won't go in detail again. So wireless service channels for industrial equipment, we are seeing thermostat I already covered. Security system again is seeing a lot of growth where you want to stream the live video. And another important thing we are seeing is in the medical field, where you want to have a medical equipment attached with the patient, and let's say a patient is moving from one place to other. Since the hospitals are almost networked through the Wi-Fi, so what they are doing is I want to continuously have the monitoring of the patient. So they are putting a device along with the patient, and that can be remotely monitored by the doctor. So this is about the Wi-Fi use cases I talk about, but there are some challenges with the Wi-Fi as a technology. Like with the BLE, I think it has proliferated very well, and a lot of people are using. But with Wi-Fi, we do see some skepticism about the technology, that it is difficult to understand and program. Even from the development point of view, everyone thinks Wi-Fi is a complex. It needs big stacks of the protocol stacks of the Wi-Fi MAC, TCP/IP you have to integrate and do. So it is complex, is what we see. and it is high power. It consumes a lot of power. That's another big concern which comes from the market when someone tries to use Wi-Fi. And you need a Wi-Fi experience with the Wi-Fi as well as the networking to do the application development. So these are the three key concerns we see from this market. And we have done a ground up product from working for almost last 2 years and launched a product named Simple Link Wi-Fi. So this we launched in mid this year with the 2 flavors we call 3100 and 3200. I will talk about these 2 later. But what it is, basically it's a single chip MCU with a Wi-Fi network controller. So it has a complete MCU for your application development along with the Wi-Fi, networking, TCP/IP all integrated in a single chip. So you can do all your typical simple applications of the Internet of Things using a single silicon. And it can run directly over the 2 AA batteries, and you can be connected to internet while it can run for a year. And it supports everything. It is secured. It supports all the security protocols to make the data secured. It has a cloud support, quick connection, a lot of things. So how it connects? So basically, So basically, like as I said, with the Wi-Fi, the first concept which comes is that it's Wi-Fi needs a very thick protocol stack of 802.11 along with the TCP/IP. So what we have done in this product is we have integrated everything inside, and what we give to user is a very thin layer of abstraction, which can run on any microcontroller, the lowest microcontroller with a 500 byte of RAM. You can have this device connected, and you can get a connectivity on that device. Then it supports the standard BSG protocols, the TCP/IP protocol. So anyone who has done the network programming can use this device without knowing anything about the Wi-Fi or the RF. It contains the crypto engine because most of the transactions you need to be secured. Your data which you are transferring over the cloud has to be secured. So it has a hardware crypto engine which can do the secure connection at a very fast rate in 150 milliseconds, what we say. So it is basically as good as it gives the security as good as you want to connect to your bank. So the kind of security you get on the web browser using 128 or 256-bit encryption, it gives the similar kind of security. And yes, it can run on 2 AA batteries. You can directly connect 2 AA batteries, and it can last for a year. And one of the key challenges which we sense from when we interact with the customer is that provisioning the Wi-Fi is complex. Now, today we have a laptops, and if let's say we want to connect to router, we have a display along with by which we can connect to the router, configure our device, and connect. But with Internet of Things, what we are sensing is that the devices are not going to have the displays with them. So how do you connect? How do you connect to router? So for that, we have worked on multiple technologies and have enabled some very good ideas, and that I will try to cover in one of my slides later. So we provide a wireless connection, wireless provisioning methods on this device to connect to your router. And to make it fast to market, we do provide the Wi-Fi, the modules for this device, which are certified for emissions worldwide, as well as they are WFS certified. So what we have done in this market, so this slide just talks about if you have a slight idea of the typical Wi-Fi on your smartphone, how it works. So in your smartphone today, you have a IC which runs this part. And this complete stack runs on the 1.2 or 1.5 gigahertz MPU you get from as a host processor. Now, this model is sustainable for the smartphones, but not for the embedded device where we are trying to even connect a washing machine or the AC or the light at a home. So what we have done in this particular product is that we have integrated all this heavy protocol stacks of the Wi-Fi, TCP/IP, security, everything inside the device. And what we are giving is a very simple driver by which you can program in, let's say, 5 function calls, you can get to the internet. That's the kind of easiness we are trying to do, and that's why we call it as a simple link to the internet. So it just needs a 7 kilobyte of flash on your microcontroller and 700 bytes of RAM to connect to internet. So any of your low-end microcontrollers which are there on your some of the embedded products can get a connectivity. It comes with a hardware crypto engines, so we support all kind of security features on this, the personal as well as the enterprise security. So it can be used for the enterprise networks as well. And along with this, we give a complete crypto engine by which you can do the encryption of your data, to make the data secured. So this slide talks about the various options we are giving for the provisioning. For the embedded device without a display, provisioning is going to be critical. So what we are come up with a new patented technology from TI, which we call smart config. By this technology, using a smartphone, you can provision any of our devices wirelessly. You don't need any wire to connect or any display to provision the device. Along with this, we are supporting the standard mode of access point and the push button mode to provision the device. And the important is the power. The important is the power for this device, where we have really done some intelligent stuff to make this device run for the battery on a 2 Duracells for more than a year. So that we say when it is always connected. So here I won't go into detail, but this is the graph where it shows that if the device is connected, you can and if it is doing a transaction, let's say every 20 seconds, it can run for more than a year. 2 Duracells always connected, more than a year you can last. So if you look at the earlier slides, earlier presentation where the people are looking for a battery life of 1 to 2 days or 1 to 2 months, here we are looking for more than a year. And if you are not connected, then even you can go for multi-years. So that's the kind of product we have tried to do, and this with the Wi-Fi, where everyone says that the technology is a very power-hungry technology and it's tough to give such a battery power. So this slide I just put, I thought it's maybe too technical, but I thought let me just put it here, where just to show the two architectures we are offering with this product. This side of the slide shows a complete SoC we are giving. SoC means that it has a Wi-Fi network processor, which means the 802.11 support BGN, along with the TCP/IP stack. And we are giving a complete M4, the complete ARM M4 just for the application development, where it's running at 80 megahertz clock and giving you 256 kilobyte of RAM. And it is independent, so whatever we are doing will not interfere into the user's application, and he can write his application at complete freedom. So this is the only product today in the market which is offering a complete M4 just for the application. This is one flavor we are offering here. Other flavor what we are offering is just a network processor, and so this is primarily for the, let's say, a retrofit market. You already have an embedded product, you want to enable the connectivity, where we are offering just a network processor with a SPI or UART, so you can connect it to any of the microcontrollers here on your embedded product. And the memory we need to run this product on a driver is around 7 kilobyte of flash and 700 bytes of RAM. So this product is already launched in market. I think we will launch somewhere in June, July, this market. And what we are offering is a complete evaluation kits for this. So this we call as a launch pad. It comes with the device onboard emulation, so you don't need to invest in any third-party emulation. What you need is just download the software which is available on the ti.com. It comes with the emulation. You can do your complete development. You can do the debugging. It comes with few sensors as well, like a temperature sensor and accelerometer, so you can enable some of the use case. So when we ship this product to the customers or to the users, it comes with pre-flash 3 or 4 demos just to show the use cases. And other one is the CC3100. So here we are offering again a booster pack format. It's a TI name. We call it as a booster pack, which can fit on any of the TI MCU. And it comes with a lot of the application which is already installed, so you can do the basic demos on this. Here, I think this is showing a Gmail chat which is enabled on this. Along with the software and the drivers, everything for the microcontroller, we are offering the IoT agents, because we feel that without IoT, offering the complete ecosystem of the IoT agent, the product is not complete. It will need more effort from the developer community. So we are offering IoT agents for this product, and we have a partnership with multiple cloud partners: IBM, ARM, Embed, ThinkSquare, Arenate, Exosite, Elementary. So a lot of partners we have for the cloud, and you can get the drivers and the IoT agents to directly connect to one of these clouds. We are supporting multiple protocols. I think like as this market is exploding, there are a lot of protocols which are coming in the market to connect to the cloud. And some of the important ones which are right now happening is the HTTP is the most predominant, but the amount of data it takes to exchange even the small information is very high. So there is another protocol which is very good for the low data rate, low power devices, which is MQTT. So we are offering all these protocols as a offering, and you can download them from the ti.com. So all these protocols, stacks, IoT agents are available, and you can, if let's say your use case needs one of these cloud partners or one of these protocols, you can download and use it. So this slide talks about some of the examples which comes with the this CC3200 Launchpad. So along with this, we offer a complete software development kit, which has around 50 different applications, including some of the use cases which I will share here. All the peripherals which we are supporting on the device, like I2C, UART, SGIO, camera interface. So a lot of those peripheral drivers, along with the applications, we are offering as on the software development kit for this product. And it's open source. We believe like it's a community which should drive, and you can download it through ti.com. You don't need to go do any registration. You can directly go and download and start using it. So this SDK comes with some of the applications around the TCP/IP stack, like TCP server, UDP servers. There is a HTTP server application which we give. So the firmware has an inbuilt HTTP server. You can directly use it. You don't need to invest on the microcontroller side on this. Then we have a MDNS as well integrated in the firmware again. So you just need to call. MDNS is basically for the service discovery, for those who don't know. So basically, let's say you buy 4 lamps for your home when you want to install in your living room or in the drawing room. Now, how to know which lamp is for which room? So using this protocol, you can start publishing, okay, I'm a lamp from the drawing room, I'm a lamp from the bride room. And your smartphone can very well know, okay, I need to go and control my living room lamp or my bedroom lamp. So that's how, again, we are offering as a part of the firmware, and what you need is just a simple API to call. We offer Wi-Fi station port, Wi-Fi direct mode on this application, and there are examples given in the SDK. We have a small application to even connect to the Gmail and do the chatting, the XMPP chat using the Gmail. Then there is an example for the email. You can have this Launchpad start this SMTP application, and you can send mail to anyone in the world. And we do connect to Gmail using the secure socket. So it does support the security to enable the secure transactions. This gives just a list of various applications we are offering, and I think this may be a good, like we are having some home automation demos, a camera demo, which I think my colleague will be showing you here. Using the CC3200, which has a parallel interface, you can do a battery-powered camera at a very low cost. Then we have a smart plug. The smart plug is nothing, basically controlling your home lights using the mobile phone. We have a reference design for this, so you can go and use it in case it fits in your needs of the product. And then there are a lot of demos around the cloud services. We have a wireless speaker demo as well, where you can do the audio streaming. We support the latest released by Apple, the HomeKit on this product. So we have a HomeKit support as well as the AirPlay audio streaming. We do support AirPlay audio streaming on this product. So a lot of feature rich, just not from the hardware point of view, a lot of content from the software point of view we are offering on this product, and which can be directly help you start very fast. Like we know that they will not directly fit in your application, but you can, that can become your base, and your ramp cycle becomes very fast. And then we are offering multiple RTOS on this, free RTOS, TI RTOS, Kontiki OS. If you know from the embedded world, we are offering all that on this particular device. With this, I will end my presentation here. There are some links which are given. So all this information is available on ti.com. What we call it is a simple link Wi-Fi. The data sheets for the product, everything is available on the TI. And there is a complete wiki. Basically, this is for the developer community we support. So there is a complete support for this device coming from directly TI. So today we have a very heavy traffic. Like we get almost 300 to 500 new queries every month on this, and this does not include the existing one-to-one. These are new queries we are getting. So there is a good developer community which are helping, which are interested in this product and are using. And the launchpad which I showed in one of my slides is again you can buy from ti.com. It's a very low cost offering we are making at $29. So you can go and buy, and that becomes your complete development platform for any IoT applications using Wi-Fi. I think with this I will end here, and I will hand over to Chandra. He is my colleague from TI again, and he is going to show a small demo using this device to do a video capture. You ready? Okay, you can just show it.
Yeah.
You can.
So what we have is, as Geet spoke over the presentation, is the 3100 and 3200 reference designs, basically, that helps you to start your reference, start your product early, and then reduce your life cycle for the product as such. So a couple of them are the camera reference design that we have come up with, which essentially connects to the launchpad, as we showed some of the reference board. We have a sensor board that connects on top of the launchpad 3200, which is nothing but your camera sensor board. So we have interfaced the MT sensors and the apnea sensors today. So essentially, the applications could be a simple door phone can kind of an applications where you are connecting a camera, you have a sensor on the outside the door or outside the house, and then when somebody interfaces or when somebody knocks it, you can see the stream content from the sensor directly onto your phone today. So what we have is we have a I'm not sure. I mean, probably this is the complete board that we have, which is having a launch pad. There is a camera adapter that sits on top of it, which uses the camera interface, 8-bit camera interface of the 3200, and there is a sensor on the raw sensor an interface to it. So what we do is, yeah, that's okay. Yeah, I'm just powering up using a power bank, and then I'm allowing it using the smart config, which is a TI proprietary app. You can connect to any access point today at home on the go. So once you are connected to your AP that is at your home, we also provide a smart app application on the Android
As well as on the Apple, on
yeah,
the iOS.
as well as on the Apple, wherein you can see the content on the camera, what is streamed. So whatever is streamed, you can view it on the app that is there on the phone. You can stream as well as you can snap it out and send over the mail as in applications. So the entire applications, what we have done is available on the SDK on the ti.com, which is launched. So it is just that you need to stitch onto your applications and do on top of it what customization the customer needs to be done. So we provide the we also provide, I mean, entire thing is available on the SDK as part of the SDK, the entire applications what we are demonstrating today. So the difference that could make out is the sensor what you end of the day interface to the device.
With that, I think we'll land here. Thanks for your time, and